My talks are typically interactive, so you're people, and you might have to pop up and interact with fruit. That's okay. Okay. I have slides. I may not use them because I have things as well. But a few slides won't hurt. Okay. Awesome. Was there anyone here at the Great British Node Conference last month? Hands up. There were a few. Okay. So at that conference, I had a RoboSapiens and LightPong. So we saw some LightPong yesterday, a new version I built this weekend. I set myself some challenges to build new things over the weekend. Some of them are in here, just for this conference. You can't see them yet. One of them is really awesome because we had a power cut yesterday, and it's relevant too. It's also shocking. Well, we're going to start off really simple. So I work for Ubiquiti Networks. We literally make an Internet of Things. We make hardware devices, so internet routers. Does anyone use our products? Do you like them? They're cheap, they work. And we make things like microwave cannons, so we can slingshot an internet connection about 14 kilometers as the crow flies if you've got line of sight at 1.4 gigabits per second bidirectional. We also make devices that you might see in the home. So if you notice that round little flying saucer with the blue LEDs on it, has anyone seen them in hotels or venues? We make them. They work. That's enough about my work. We're here to talk about the Internet of Things. Can anyone give me a definition for the Internet of Things? Andrew, you're a good chap to give us a definition. What's your definition of the Internet of Things? Take as long as you want. We've got a TARDIS now.
So it's the internet enhanced by things that aren't held by a person. So you've got people and their mobile devices are the internet, and then the things are the things where there isn't a person near enough to reset it when it crashes.
Okay. So the Internet of Things is so important that Oxford gave it a definition. When Oxford gives something a definition, it's pretty important. That happened in August. So according to them, the Internet of Things is a proposed development of the Internet in which everyday objects have network connectivity. I think that's a pretty boring definition. And here's my definition of the Internet of Things. It's a proposed development of the Internet in which everyday people can easily network everyday objects. That, to me, in a nutshell, is the Internet of Things. It's not about the Internet, and it's not about the things. It's about you interacting with all of the above. Does that make sense? I'll delete that in the official version of the slides. And I come from a complex event processing background. That's a big scary word like communicating sequential processes that Malcolm mentioned yesterday. So I build CEP engines. So they're trading systems or scalping engines, arbitrage engines. Until recently now I do hardware products. And I build these things called CEP engines. And if you squint at a CEP engine, it's actually quite simple, right? We've got signals, as mentioned by Andy Piper earlier, and we send streams of these signals through something like MQTT or other protocols, and we process them in some way. And I've been focused on analytics and processing for quite a number of years. So I build these analytic processing systems. I think, Yodil, you used to build trading systems as well. You're now in the thing industry. That's a thing, isn't it? All the finance people are decamping into thingland. Go figure. But this talk really is about things. And some of my favorite things actually come from some really awesome engineering companies like Philips with the Hue. Who has not heard of the Hue? Right? One of the world's most ubiquitous objects is a light bulb. It's a really simple electronic circuit as well. And I have a few light bulbs in my bag, but they're strange, weird metal light bulbs. They're a bit different. And the Hue is basically just a hub for a light bulb. And you can connect to the hub a number of light bulbs, and then on your phone you can control the color of the bulb. But, first world problem. 180 quid for 3 light bulbs and a hub. That to me is wrong. right? The Internet of Things is supposed to connect everyday people to everyday objects in interesting ways. We're supposed to make it simple. I think 180 quid for a couple of light bulbs is just capitalism gone mad. So I prefer a more human or social definition of the Internet of Things. So that's as much talk as I can give, or I can talk about CEP, or we can do things with things. Who wants to do the thing? Things with things. More light bulbs. Who knows what this particular thing is? It's the Li-Fi. It's a really interesting light bulb, right? This is a light bulb that actually sends the internet throughout your house. So this is a Li-Fi, right? Light-powered internet. It's pretty awesome. It's like the Chirp, only it's sending data with light rather than with sound. That's pretty cool. Who can see the Internet of Thing in this picture? Come on, give me a guess. There's not a lot on the wall. The radiator. There's a crazy French company who came up with a radiator that uses thermal energy from supercomputers to heat your home. So they will install a supercomputer on your wall, and they will send it compute workloads. Isn't that awesome? That's a thing. You can solve cancer and warm your arse at the same time. Isn't that brilliant? And you get a warm arse for free. And here's another Internet of Thing, right? This is a Parrot AR drone 2.0. It's got a mega load, or 9, common internet protocols and some custom protocols built into it. It's basically a flying access point. So, you know, it's a router with wings. We're going to fly one now. So I'm going to use Michael here. Michael was generous enough to lend me his copter from Resin. So thank you, Resin, and thank you, Michael. And Michael is going to fly with fruit.
Actually, I think we should get someone else to fly.
Let's guess who wants to fly with fruit and is not allergic to apples or bananas. Don't want any health and safety incidents just yet. They'll happen anyway. Okay. Right. I'm going to plug out for a second. Okay. I have a mildly broken leg, so this is difficult for me.
So who wants to fly?
Malcolm Sparks, do you want to fly a plane? Who wants to fly a plane? Helicopter thing? Any volunteers? It's really easy, allegedly,
Good.
if we've got it right.
The least technological person in here.
It's okay, it's powered by bananas. It can't be simpler, right?
Okay.
We've tried to take all the technology away. So I'm going to take off for you.
Yeah.
And you've got an up banana, a down banana, a clockwise rotating banana, and a counterclockwise rotating banana.
Okay.
If something goes wrong, you have an emergency apple. So if something goes bad, like someone in the audience is going to die because of your flying,
Yeah.
which would be hard because it should hover and not move. So we've tried to minimize that. Hit the emergency apple.
Okay.
Don't eat the emergency apple, then we have no
Someone's
contingency.
already eaten it.
That was me. I got hungry. Are you ready? Okay, so we have to connect to the copter, so I'll do that for you. Unfortunately, you can't actually see this. I'm just changing the internet connection. And I'm going to fly, using Node, the copter. Hopefully.
Sorry.
It's
That
bad
might
fruit,
not-
I'm afraid.
It's quite. Shall I?
You can touch it again. Do you want to try again?
Wait,
He doesn't look like he trusts me.
onto this?
Oh, you have to hold that as well. I forgot one of the rules.
There we go.
I'm better at writing code than I am at bananas. Okay.
So I hold on to this and then. Okay.
I didn't bring my soldering iron today.
Great.
I used it yesterday. It was handy. Oh, I should probably stop now because I'll kill your hands. While he's doing that, I've got some really cool things in my... Where's my bag? It's in my bag. So, light bulbs. What's the weirdest light bulb anyone's seen here? No light bulbs. They're all round, aren't they? boring. So you can get light bulbs in interesting shapes. There aren't many handheld light bulbs. I have a special light bulb. It's a very primitive light bulb. And it's an awesome light bulb. The actual bulb is from IKEA. It's a replaceable bulb. We had a battery. It broke. Oh. It's actually got an ignition coil and it sends awesome sparks about half an inch when it works. That's for, where's James? I was going to give it to the least responsible person in the room, which is actually me. But the second best thing would be James. So this is for James, this is for him. I'll put more batteries in it. And I've got another, hopefully, working light bulb-like circuit, which is, again, mounted on drills. It's a hobby of mine, is using drills for weird and wonderful purposes. As you can see, this has a missile switch. It's not lethal. So, everyone see that? So we can arm this thing. It's now an armed thing. It's awesome. I would give it to you to play with, but it might be dangerous, or you might drop it and it might break just like that did. So I'm going to operate it for you. They're car horns. So I take the Internet of Things quite literally. I see things and they shouldn't be together, so I make them work together. This is a 12-volt car horn. It's awesome, isn't it?
Sounds like me.
I made this for you over the weekend and it broke, so I couldn't demo it. Or I'm stupid, one or the other. Oh, there you go. You got a spark. It's kind of like a... I did say there might be health and safety issues, so here's your Internet of Thing.
Okay.
Just for you.
Right.
Don't touch the working end, it might kill you. It's about 30,000 volts. Okay. That plastic bit is safe. You can touch that. It's awesome.
And what?
I'll put new batteries in it and you can make light and sparks.
Yeah,
with new batteries. I had so much fun after making it, I may have drained the batteries. They were new when I put it in, but...
This is what you're saying we needed for last night?
Yeah. That's your... See, now you have a handheld power supply at all times. It's awesome. Anyone want to play with this? You know how it works now. It's safe. Don't worry about it. Don't drop it. There's an explosive battery in the bottom. Yeah? It's an 11.1 LiPo, so you typically find them in remote control cars. You know the remote control cars that often explode? It's using one of those batteries. Which is why the not dropping is important. Which is why you don't want to give it to someone before they know it makes a really loud, scary noise. Because it would be shocking, and then it would drop and go on fire, and there would be lots of hassle and kind of things like that. It's not very good. Cool. Do you want to have another go? Let's have another go. You ready? Are we connected? Okay. You ready, Michael? It's great having an emergency Michael as well as an emergency Apple, because he's mobile. The Apple just stays there like an idiot when things go wrong. So let's take off.
Okay, does someone else want to have a go?
I think it's bad fruit, actually. It's been standing there too long. We should have put someone in the fridge. We could try with the outdoor hole. Paul, you do that. I'm gonna...
Well, give it a try. What's the worst that can happen other than blinding someone?
Well, we've got dangerous objects and no one's dead yet, so I think we've got a responsible audience. Give yourself a round of applause. Okay. Woohoo! Okay. That's enough of that. what I really do is streams. So if that did fly correctly, it's using a CP engine. So I used to do this stuff. I was talking to Andrew earlier about this. This is the version of Node-RED that I'm used to. So I used to work for a company called Stream-Based Systems. They're now owned by TIBCO. And I used to write algorithms using this visual language. So the algorithms I wrote, though, were trading systems, trading engines, buying and selling things. And it's a visual language, as you can see. You configure these different properties. It's very similar to what Node-RED is trying to achieve. And Node-RED does it in a very interesting and accessible way. It's kind of like Scratch, which is a very good and interesting language for children that I teach to my kids. And Node-RED is making very complex event processing facilities available to ordinary people. So I think Node-RED is important. You can do it in a real programming language, people that scientists or computer scientists or engineers use. And Node.js is one of these languages where you do A.pipe, B.pipe, A. So it's kind of a Unixy-like way of connecting things. In this case, an A thing and a B thing to an A thing. So it's a bidirectional connection. And code would look like that. So for the non-developers here, I apologize for the code. I do have visual slides for all of this as well. I'm pretty sure I stopped it. I did not stop the program. Kill the fruit. The fruit is dead. Long live the fruit. Okay. So this is a little piece of code by Max Ogden. It uses streams, and it pipes these streams together. So think of this as just sending in signals for those of you that are non-technical. I came up with something I call embedded event processing. It's like complex event processing minus the complex, right? Because that's the thing that kept everyone away from it and really killed it as a meme 10, 15 years ago. So it was a really cool idea, destroyed by a terrible, atrocious, horrible name, complex. No one wants to think about complex things. So embedded event processing is simple. I'd have to take the 20% of CEP that's useful and only code for that. I just leave the rest of it, the complex stuff, out. And I've got, I call it EAP, because it's not scary. Makes perfect sense. And it's an open source library. There's versions in PHP that Ian Barber from Google wrote. It's been implemented in Clojure by two crazy guys in ClojureWorks. It's available in Java, Node.js, and a bunch of languages. It's got a sister project, which is called Beam, also on GitHub. And that does flow control. So you saw with Node-RED, we have a visual paradigm. This is basically like streams in Node.js, but adapted for compute-oriented workloads. Okay? It goes meta from here on out. I apologize. Or did it start meta, and is it normalizing? You're the audience, I don't know. So in Node-RED or in any of these stream processing engines, we have inputs or sources. Okay? We have sinks, which are where streams of data goes to perform some action or to die or whatever. And we have operators, so we can do things. Okay? So this is a lot less scary than code, right, for the non-developers amongst us. Okay? We have pipelines, so that scary A.pipe, B.pipe, A construct you can represent visually. So we've got a stream called A performing some operation and a stream called B that the result of that operation is going to. It's really simple. So this is what a filter looks like in scary code. A filter is an operation that you can ask a yes or no question to. It's called a Boolean. And a Boolean gives you a yes or no answer. Yes, it's true, the light is on, something like that. Okay? And we can write this strange coding language to say, given an input stream of data, compute some result, which is the data odd or even. And if it's even, pass it on. If it's odd, just drop it on the floor. I don't care. Okay? So you can filter data with this. You can transform data, so give me an apple, make a banana. That's actually hard to build. It's possible, but hard. It must be possible. Do anything you set your mind to. And we've got some built-in functions, so I've got statistics packages for this, and a few other things that you can hook in rather than, once you've written these functions, you can just reuse them. It's like a library. If I write a statistics package, you just use it. It's the same as Node-RED. You've got these packages of things you can drag and drop and configure, right? So it's a library of digital things that you can interact with. And that makes it easy to, so if in Node-RED what you want is a picture of a light bulb that you can turn on and off rather than a globular thing. This is my opinion. To put a nice little picture of a light bulb or a switch so that it's more intuitive. Anyone here have children, young children, kind of 1-year-olds, 18-month-olds? What happens when you give a child a book these days? Like an 18-month-old, they go, "It's broken. It doesn't work. Not like your phone. Your phone's awesome. I want a phone." You're not getting an iPhone. It's an 18-month-old, right? But to them, that's intuitive. We succeeded in the UI field enough that a child, just seeing someone interacting with a phone, thinks everything must work like this. Why? It's broken. And they get really frustrated. And we should start thinking like them, because in 10, 15 years, these crazy people will be employing us. And they will have very strange demands of us that are alien to us. This coding environment is normal to us, right? Not to them. They want to touch all the things. Touch the things. So there's branches as well, right? So we don't just do trivial functions. We don't just filter things or transform things. We also scatter things, right? We want to do something depending on a thing. So we might want to, if it's an apple, do apple-like things. If it's an orange, do orange-like things. And the Nodecopter exactly did that. So if I hit the up banana, go up. Or actually, just crash. If I hit the down banana, go down. Or just crash. If I hit the rotate clockwise banana, just crash. Forgot to implement that or whatever. So that's branching. We might want to combine things. So when we combine things, a computer scientist might call it lambda calculus or something scary. It's basically just taking multiple things we've split, do an apple-like thing and an orange-like thing, and then combine the result. Did the thing you did with whatever work. So send a result statement. You want to merge them together and do some other processing based on that result. Out of those really simple constructs, there's only 4 things here, 4 digital things. The ability to branch, ask questions, perform some action, transform a thing, and to combine them with an ability to get input and output, these streams, these sinks and sources. You've got everything you need to actually define and constrain a paradigm to. People don't need more than that. CEPs have multiple dimensions, so you can describe some very complex temporal or data entities in algorithms that you don't need for basic interactions with basic things. And I think the 20% or 10% of this very complex, well-developed space that's useful is that small subset. And I picked an arbitrary subset of that I think is important, and I packaged it in this Eap and Beam set of open source libraries. So if you like it, use it. If you don't like it, change it, fork it. It's awesome. It's all free. And this is the algorithm that's running inside the Nodecopter, so it was running on the laptop. Basically, it's just a filter. So the makey here, which is connected to the bananas, is connected over USB into the laptop. It's performing a filter operation. It's then for up, down, left, or right, it does the appropriate action. It actually speaks to the speakers. I had the sound turned off. It'll say flying up, flying down, stuff like that. That's it. It's a really simple algorithm. That's an entire algorithm to fly a helicopter, and you can see it's trivial, right? So my 18-month-old, well, maybe when he's 5, should be able to use this kind of interface in Scratch or some environment to configure things. And we as adults should be able to do that too. Whether it's connected to the internet or not, we should be able to take ownership of those things. There should be convenient, well-known, well-understood, simple interfaces that we can configure in easy ways. So I basically want to take the last 10 years of my life, of the complex systems I've been building, and make it that simple. And I think if we can do that as a community for the Internet of Things, whether we're vendors with my work hat on, or we're just consumers or hackers or makers or designers, I think we've got something very successful to contribute. But it all depends on you guys, people in this room in particular, to make this work. Because we can take the simplicity of educational tools like Scratch or projects like Node-RED, for example, and empower ordinary people, like we did yesterday with the hacking over here. Who had fun hacking over here yesterday? Did you program before yesterday?
I've done programming.
You should have said no. Should have said no. Theatrical element is gone. Yeah, that. So, and you got up and running with the Arduino, Blinking, and Node.js, and all this stuff yesterday in hardware. That's empowering, right? And once you start with something like that, Why stop? You want to continue. You want to let other people have this enjoyment. You want other people to have that privilege to take their things and own them. It's not a license, right? It's not your thing. It's not your printer. I bought the printer. I can use it for what I want. I can take out the motors and make it do something else. I can turn a drill into a car horn or an electrotherapy device with a bulb on top. That's it.
I was going to say ask questions later over beer, but knowing Derek, I would say if you're going to do that, do it earlier in the evening. You could do another demo?
Want to do a demo? Let's do another demo.
And it may be that we're actually going to now fly the Node copter by pouring coffee as well, because we've got a flow meter on the coffee. So by pouring the coffee, as the coffee pours out, the Node copter could fly up. So we're also going to hack that this afternoon as well. But in the meantime, what's Mick showing? Fruit flying Node copters? Fruit? What are you showing?
We could make a thing.
Do we want to do that? There's no how it'll fly
If you
now.
want to do it now.
Because the whole
otherwise
stem.
we're moving on.
Let's fly it.
Okay, let's fly it.
Oh God, I have to sit down again. That's
So yeah,
complicated.
the coffee thing, as I say, it is speculative, but it is really something that Alex does. And it's a bit absurd, the idea, why would I fly a helicopter when I pour a coffee? But as we heard this morning, you might be a brewing operation and you're thinking about it. Bottom line is, water's really, actually, while we think that water is cheap, it kind of isn't. There are vast swaths of the US, for example, at the moment, where, frankly, they could run out of water at any time. We piss it away all the time, and we should be doing a better job of monitoring it. So why would I be instrumenting a coffee machine? Because we might want to save water. The coffee beans themselves, with global warming, it turns out that in some of the geographies where we make coffee, that's an issue, and the fruit is flying the Node copter.
I've been wanting to eat that banana for the past 2 hours.
Whatever you do, don't eat the banana.
They're clean alligator clips. I sterilized them last night myself. One of the things they don't tell you with these quadcopters is taking off and flying is easy. Meh, landing. Just crash it. It's more fun.
Breaking the case doesn't help either.
So what we think, or why we had trouble getting control of this, is the dark floor. There's a camera on the bottom of this quadcopter, and it looks at the ground for texture and context, and the high contrast black floor actually impedes it from knowing where it is, so it can't hover, so it kind of drifts, which is why we tried to change the color of the floor.
And also, we broke the case.
And we may have crashed it a few times. The fruit was very badly behaved earlier. It's well behaved now.
You've got to buy just one of these.
Buy proper fruit. Organic fruit works better.
Is Matt from Berg here, or did he bugger off because my scheduling? So, nice. So yeah, I'll try and